Very good morning, children. In the previous class, we had the introduction about the theory of acids and bases. In that, how Arrhenius has defined an acid and how Arrhenius has defined a base, and what are the limitations in the acids and bases of Arrhenius theory that we had. And in today's class, we will be seeing about Bronsted-Lowry theory. Bronsted-Lowry theory of acids and bases. Okay, Bronsted-Lowry theory of acids and bases. Okay, so while this theory is given the preference means he has explained the drawbacks of Arrhenius theory. Explained the drawbacks of Arrhenius theory. Explained the drawbacks of Arrhenius theory. So what is the major drawback in the Arrhenius theory means what he said, that an acid is a substance which has H plus ions or which improves H3O plus ion concentration. That is considered as an acid. And the base is a one which has OH minus ions or which gives more OH minus ions. And the theory is limited only to aqueous solutions. That is the major problem. And he could not able to explain about the acidic nature and basic nature of the substances which are not having H3O plus ions or OH minus ions or H plus ions. And those are successfully explained by the Bronsted-Lowry theory of acids. So what are the main postulates of this theory? Okay, what are the main points? Postulates means what are the main points of Bronsted-Lowry theory? Postulates of Bronsted-Lowry theory. Of acids and bases. What are the main postulates means? He defined acid as a proton donor. Acid is a substance that donates the proton. Okay? And a base is a substance which accepts the proton. Okay? He defined the things based upon the proton. Proton acceptor and proton donor. Proton means H plus. So the acid is the substance. The acid is a substance that donates protons to any other substance or substances. That is called as an acid. And HCl acts as a proton donor, and hence is called an acid. It is called an acid. So HCl gives rise to H plus Cl minus. Okay. Next, what is a base? So the base is a substance that accepts protons from any other proton donors. Okay, proton donors. So NH3 acts as a base. It is a proton acceptor. If you take NH3 plus H plus, is forming NH4 plus, which is basic in nature. Okay, so it is totally called as a protonic concept of acids and bases. We also call it as protonic concept. Why? Proton only, based upon the proton. Proton is nothing but H plus. Okay, electron lost hydrogen is called as proton. Only protons are present in that. Okay, the acid is a substance that donates protons. Okay, that donates protons to any other substance. Proton donor is called as an acid, and proton acceptor is called as a base. This is the major concept given. So what he said, even if there may not be, okay, even if hydrogen is not there also, that can be considered as an acid based upon if it donates the proton, that's all. And the substance which can be accepted as an base means which accepts the proton, that is called as a base, according to Bronsted Lowry theory of acids and bases. You can note down these points. And the next we have neutralization. Okay, so what is a neutralization? Before going to neutralization, we will have a discussion regarding conjugate acid and a conjugate base. Fine. We will be having what is a conjugate acid and what is a conjugate base. So an acid on losing a proton produces a species that has proton accepting tendency. That means the tendency of a base. The base so formed is called conjugate base. The base so formed is called conjugate base of the acid. That is, suppose if you take HCl, it gives H plus and Cl minus. The Cl minus is called as conjugate base. Okay. In the same way, we have conjugate acid, means which is a base, the base on accepting a proton produces a species that has proton donating tendency. That means the tendency of an acid. The acid so formed is called conjugate acid of the base. Okay, conjugate acid of the base, that is NH3 plus H plus gives rise to NH4 plus. This is called as conjugate base. Sorry, conjugate acid base. Conjugate acid of the base NH3, that is the case. Okay, so what is a conjugate base? So what is a conjugate base means an acid HCl losing a proton produces a species that has proton accepting tendency. See here, Cl minus has the proton accepting tendency. So that's why this Cl minus is called as conjugate base. Okay, this is called as the conjugate base. The base on accepting a proton produces a species that has proton donating tendency. See here, NH3 plus H plus, it has NH4 plus. So now what? It can donate to a proton to form again NH3. That means the tendency of an acid. Okay, proton rotating tendency, that means the tendency of an acid. The acid so formed is called as conjugate acid of the base. Okay, see, this is the tendency of the base and this is the tendency of the acid. That is the difference. Conjugate acid and conjugate base. Hope we had a clear discussion regarding what is an acid, what is a base, and now conjugate base and conjugate acid. Conjugate base means what? From the acid, it produces a species that has proton accepting capacity, and here proton donating capacity. That is called as the conjugate base and conjugate acid respectively. The next we will have the definition of neutralization. So generally now you have seen this all. So what is neutralization we will see now. According to Bronsted theory of acids and bases, what is a neutralization we will see. Right. Now according to Bronsted Lowry theory, what is the neutralization concept we will see. So neutralization is defined as the transfer of proton from the acid to base to form a conjugate acid base pair, that is HCl plus NH3, that gives NH4 plus C minus. See here, this is an acid and this is a base. It is giving what? Conjugate. What is this acid? And what is this conjugate base? Okay. So this is called as neutralization. So neutralization is defined as the transfer of proton from the acid to base to form conjugate acid and a conjugate base. So this total theory, as this theory total is based upon the proton transfer, this is also called as protonic theory. Okay, I am writing here as this theory also known as protonic concept of acids and bases. Which theory is also called as protonic concept of acids and bases, means Bronsted-Lowry theory of acids and bases. Okay, so this is a brief regarding the Bronsted-Lowry theory of acids and bases. In this we had a clear discussion: what is an acid, what is a base, and what is a conjugate acid, and what is a conjugate base, and what is neutralization. Now we will see what are the drawbacks and the limitations of this Bronsted-Lowry theory of acids and bases. Please make a note of these all points. Okay, we will be discussing about now the limitations of Bronsted-Lowry theory of acids and bases. So majorly, what are the limitations of Bronsted-Lowry theory of acids and bases? First thing is the acidic nature of the substance. The acidic nature of the substance says do not contain hydrogen, cannot be explained by this theory. This is the limitation. See, if they are not having hydrogen, he failed here also. Why? If it has to donate proton, means it should contain proton in it. So here you see CO2 and SO2. These two are not having protons, but they are acidic in nature. The same failure was also with Arrhenius theory also. And next, what is the thing is, sir, then why this theory is given that much of importance? You will see in the merits. I am saying the limitations. And Bronsted-Lowry theory mainly involves proton transfer. Only proton transfer is the major concept. Whereas in Arrhenius theory, what is the concept? Soluble in water. It is limited to only water. Okay? So proton donator, proton donation or acceptance being a relative tendency of substance cannot give the absolute acidity or basicity of the substance. So these are the limitations of Bronsted-Lowry theory. So what is the major limitation? Means it involves only proton transfer. The same, again, the one which is not having H plus ion cannot be treated as an acid according to this theory. But carbon dioxide and sulfur dioxide both are acidic in nature only. So this was again a limitation. Then why we are considering this? Means we have some merits in this that we will discuss now. Please make a note of these 2 points. Though it is having some limitation, but there are some merits in Bronsted-Lowry theory of acids. Previous Arrhenius theory, what it explained, only it is limited to the liquid phase only. But Bronsted-Lowry theory has explained the nature of the acids in gaseous phase also. So that is the major merit. So the acid and basic nature, the acidic and basic nature of substances in gas phase could be explained by this, explained by Bronsted-Lowry theory. That is a major merit. And the next thing is Bronsted-Lowry theory is not conformed to aqueous solution. Bronsted-Lowry theory is not confined. It is not confined to aqueous solutions. It is not confined to aqueous solutions. It involves a broader coverage of acids and bases in comparison to Arrhenius theory. And the next merit is the basic nature of substances that do not contain OH minus ions could be explained on the basis of protonic concentration. So these are the merits of Bronsted-Lowry theory. That's why we are studying. See, Arrhenius theory has its own merits and demerits. And what are the demerits of Arrhenius theory that were overcome by Bronsted-Lowry theory? And that's why we are reading this. See, we are accepting Arrhenius theory and we are accepting Bronsted-Lowry theory. We are not rejecting both of them. What is best in Arrhenius, that is accepted, and what is best in Bronsted, that is also accepted. Both are accepted theories only, with some limitations and drawbacks. So these are the merits of Bronsted-Lowry theory. In the next video, you will be having the discussion about the next theory, Lowry's theory of acids and bases. So totally in acids and bases, we have three theories. Presently, we are following three theories. One is Arrhenius theory of acids and bases, and second one is Bronsted-Lowry theory of acids and bases, and third one is Lowry's